Okay, so the next step of this problem is to now make the substitutions that we talked about earlier. So again, we're going to take our y and swap it out with xv and swap out y prime with v plus x times v prime. So we've got our original x squared. And then again, the y prime is being replaced with v plus x times v prime. And that's equal to 2 times y squared. Well, y is actually x times v. So again, that's going to be squared, and then minus x squared. And let's put a little wall up here just to divide those. All right, so now we distribute, and we're going to have x squared times v, plus now an x cubed times v prime. And then over here, we're going to have a 2x squared v squared, and then minus an x squared. So now the next thing we want to do is bring all of the non-v prime terms to one side. So when we do that, we're going to have the x cubed v prime still over here, but then we're going to have our 2x squared v squared minus x squared minus x squared v. And then from here, all right, so now for the next step of the problem, you will notice that we have an x squared common to every term. So we're going to have a x cubed times v prime is equal to a factored out x squared times 2v squared minus a v minus a 1. And now we can divide both sides by the x cubed, and we can also rewrite v prime because now we have a separable equation. And remember that the v is a function of x, so the v prime is actually dv dx. So this is going to be x cubed times dv dx is equal to x squared times 2v squared minus v minus 1. And now if we go through and divide both sides by x cubed and multiply both sides by dx and divide both sides by the 2v squared minus v minus 1, we will end up with a dv over top of 2v squared minus v minus 1, and that is equal to a 1 over x times dx. And now to integrate this, we're going to want to go in and we want to see if we can recognize this as something from before or factor it. And you'll notice that this does factor. It factors as 2v and a v, and the terms are going to be a plus 1 in the first term and a minus 1 in the second term. And that's equal to still 1 over x dx. And just to double check that, that's 2v squared minus 2v plus 1v minus 1, so we are good. So the next step is going to be to integrate both sides of this, and that's where things are going to get challenging because we're going to have to use partial fraction decomposition to factor this over here. So let's go for our rewrite off to the side. And off to the side, we're going to have a 1 over 2v plus 1 times v minus 1. And again, that's equal to a partial fraction decomposition. Since they're both linear factors and a first power, that's a over 2v plus 1 plus a b over top of v minus 1. And now we multiply through by LCDs. So we've got 1 is equal to a times v minus 1 plus b times 2v plus 1. And we can now choose different values of v to find the value of a and b. So let's pick v equals 1. If we pick v equals 1, we get 1 is equal to 0 plus 3 times b. So that makes b equal to a 1/3. And the other value of v that we can pick is equal to a negative 1/2. If we substitute in, we still have 1 over here. Then we've got a times a negative 1/2 minus 1 plus 0. So 1 is equal to negative 3/2 a, and that's going to make a equal to a negative 2/3. So we're going to have those two coefficients for our partial fractions, And in the next video, we'll go in and actually do the integration and solve the problem.